Hello everyone. I'm Andia from ThinkMo. I'm teaching Sci course now. As of today, I'll share with you some technologies related to CCNA, CCNP, CCIE. Our topic today is: how does MSTP achieve fast convergence? So those of you who have taken RSTP, it should be clear. It involves a fast convergence mechanism. The root port is involved. Edge port. Then there is the PA mechanism we mentioned. It's called a proposal or agreement. Proposed consent mechanism. In RSTP, it's a normal PA mechanism. Of course, MSTP also has it. First, let's get to know: what is the PA mechanism? The PA mechanism has the normal type. There are also enhanced ones. It's a little more stable. But between them, the difference is not huge. So what is the PA mechanism? Let's look at the RSTP courseware. The reference to the PA mechanism. The first is to specify the port. Enter the forwarding state quickly. Work mode is point-to-point. When the link is in full duplex mode. In the process, there are two types of packets: proposal and agreement. In this topology, we can see that this is a root. Here's another switch. Two switches in total. During this process, if the two switches are not connected, now I'm going to connect this wire. At this time, two switches, whether S1 or S2, they declare themselves the root bridge. Then the specified ports send corresponding packets to each other. So this port starts out. It identifies itself as the specified port. This port also considers itself to be the specified port. The two send a corresponding packet to each other. And then you compare and you find that S1 is the root. This is the switch down here. Then no packets are sent out. It will wait for the S1 switch. Proposal message. Request quick migration. That means a quick transition to a forwarding state. So this switch down here, S2, after receiving the proposal message, next it will put the upstream device, the connected P1 port. Set this parameter to the root port. Then block all but the edge ports. All other ports. If the port is already blocked, you don't have to block anymore. Based on this case up, send an agreement packet. This port is the equivalent of the status has been set to forward. That's what we're talking about. The state of forwarding. This port is what we call an RP port. Root port. And S2 goes up at the same time. Send the consent mechanism. I'm already in a state of transformation. P0 port of the S1 device. Only at this point does it enter the discarding state. In other words, the blocking state. Transition to a forwarding state. This completes the negotiation mechanism. This is what we call RSTP. It's also MSTP. All the PA mechanisms in there. So what problem does it solve? Under normal circumstances, ports of two devices S1 and S2. How many seconds does it take to complete the forwarding of the data? Let's say this port sum. How long the following ports need to go through in order to participate in the normal data forwarding. So the question is, I'll leave you to think about it. And then it comes to an enhanced PA mechanism. It's basically the same as what we've been talking about. The normal PA mechanism is similar. So what's the difference? So let's start with everybody. They all think they're the root bridge. So the port on the root bridge. Both are in discarding state by default. It's called port D. And then S1 is the root. Then the device will Send out the proposed message. Downstream S2 this device received. And when I received it, I'm going to put this port. Change from port D to port R. This is what we call the root port. Changes the root port and blocks the divide. All ports except edge ports. At this time, is made by upstream equipment. The agreement packet was sent. It will only be this port. The state is changed to forwarding. Certainly in the process. The following S2 switch. The following ports are blocked. It also has to go up. The agreement packet was sent. But the RP port is temporary. It cannot be forwarded yet. It has to wait for the root. The agreement packet was sent. The notification RP can be changed to the forwarding state when it's done transforming and reply a packet up. Only port D can enter the forwarding state. The distinguishing point is the root port. You entered the forwarding state first. It's going to come from this switch up here. After the agreement packet is sent to enter the forwarding state. So the ordinary PA mechanism, we can think of it as two interactions. An enhanced PA mechanism, think of it as three interactions. That is, the port goes into the transition state. Is it up to S1 or S2 itself? That's all for today. If there are any other skills you would like to learn, feel free to leave a comment or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.